What's up, everyone? It's Friday. Hope everyone has had a good week and is getting ready for the weekend. And I'm just gonna do what's hopefully will be a quick video on a repair request that I got in today. This is for a Vevor Mini Centrifuge, the MC-7S. But anyway, we got a bunch of these not all that long ago, brand new, because it was either a sale or they were just really affordable, and got a request for one. Now, if you're not familiar with these are sometimes called microfuges or microfuges, and they can spin really tiny tubes like these PCR tubes or Eppendorf tubes, and they really all operate like there's a similar one right there under the same sort of principle. You press this lid down and that will engage the motor. Oh, this guy likes to dance around. Then you just press it again and that's it. So I got a service request stating that the rotor would not spin when you close the lid. And anyway, I have the thing apart in my space, so let's go take a look at it. All right, so this is the microfuge taken apart, and you can see it's very basic. You've just got this motor here. This is look at this though. What is that? Look at that. What the hell is that? Now, this sits right here. Look at that. It looks like rust, but I don't know if that was grease that was put in during the manufacturing. Could be sample somehow getting in here, but I don't know. The rest of it looks fairly clean. So, anyway, it's pretty straightforward. I mean, you've got two diodes on this board, two resistors, it looks like. I don't know if there's anything under all that crud. This is the input jack for input for power. A power switch, a MOSFET right there, and then this 2-wire motor. There's a capacitor on the back of the board. Then it moves on to this board, which is the lid switch, and there's another diode on here, but I mean, pressing the switch will allow the motor to turn on. So yeah, and there's a little bit more of this stuff. I don't know what that is. The end user did say that they do clean it. They'll spray it with ethanol, and they were wondering if that's what caused it. I really don't know, but we're gonna try to clean it up and then see if we can get this thing to turn on. All right, so we cleaned up that growth or whatever was on that board. Looks a lot better now, and at first it would not power on even after cleaning everything up, and upon closer inspection, R1 right there was open. It's a 15K resistor. R2 is a 1.5K resistor, so I did replace it, and now it works. Cool. So I thought it'd be cool to go over the circuit for this device, and so I drew it out here, and so we got 24 volts coming in from the wall wart power supply. We got a diode here that's maybe for protection. This is the power switch. Got electrolytic capacitor here. This is that resistor that we replaced, the 15K resistor, which is going onto the gate of this MOSFET, which we'll get to in a second. This is the SPDT lid switch, and this is the motor, flyback diode. So when the lid is open, this portion of the circuit is closed, and so there is no voltage being delivered to the motor, so it's off, And then when this switch is closed, when the lid is closed, this completes this circuit here, and so the 24 volts can come through here across the motor. The MOSFET is on, and so that 24 volts is a path to ground, and so that will turn the motor on. Now, this is a brushed DC motor, which means that it has brushes in there that make contact with a commutator to change the polarity of the the magnets in the rotor. So it really doesn't need a driver circuit unless you want to change the speed or the direction. Now, this configuration, the flyback diode, which is there to give any EMF generated by the motor a path to back EMF, a path so that it doesn't damage the motor. This MOSFET, generally, if you wanted to have some speed control, you would have a PWM signal here, a pulsed width modulation signal being sent to the gate, so that you could control the current. That's not what they're doing here, obviously. However, this MOSFET is being used in a way to regulate the current that is being delivered to this motor. It's almost acting like a current limiting resistor. That's what it seems like, at least. And the reason I think that is because the gate voltage that I measured in circuit is roughly at 2.2 volts. The gate threshold voltage is anywhere between 1 to 2 volts, so it's just above that. And so in that, generally with MOSFETs in that active region, they have a very linear response there, and it's almost resistive in nature. So that's what it seems like. This is really acting as a current limiting resistor to regulate the speed of this motor. Now, there's no speed control, there's no potentiometer that you can change the speed of this, but I think that's basically what they're doing here. And this is the data sheet for that MOSFET, and you can see if we look here at the gate to source voltage on the X, and then you've got drain to source current on the Y, which is the current being delivered across that MOSFET. You can see here at 2 volts, and again, this is for a drain to source voltage of 15 volts, but if you're just looking at the curve, you can see that the current in this region is going to be low. So it looks like they're trying to perform some sort of current limiting here. That's what it seems like, at least. Okay, not ideal. A lot of the solder mask got lifted up with the cleaning and the reflowing of solder, but it looks a lot better in my opinion. And allow that to cure under some UV light, and it will be ready to go. Well, folks, there you have it. Forgot to turn it on. Very nice. And the lid works. Yep. Okay. Alright, that's a wrap on that one. Hope you guys found that interesting. If you have any feedback, leave it in the comments. Hope you guys have a good weekend, and if you live in Philly, try not to freeze to death next week. I'll catch you at the next repair. Alright.